Recall that slope is the change in y as x increases by an additional unit. A t-test on slope determines whether there's any slope at all. The null, beta equals 0, no linear relationship. The alternative, beta is not 0, there is a linear relationship that may be positive or may be negative. Suppose in the amusement park example that on average people spend about $50 a day on food and merchandise regardless of the price to get in the park. There would be random fluctuation due to chance, but the true regression line would be the red horizontal line at y equals 50. The slope would be 0, no change in y as x increases. The blue line would be the least squares regression line for such a sample set of data, and the sample slope's not exactly 0, but it doesn't differ enough from 0 to believe it's anything other than random chance fluctuation. Here's how the test is run to determine this. This is a t-test on the slope of the regression line. The null is that there's no linear relationship between admission price and revenue spent on food and merchandise, and the alternative is that there is a linear relationship. The residual plot gives no concern regarding linearity, consistency of variance, or normality of residuals, and AP is going to provide us the standard error of the slope like they would in a table such as this. We're looking at a standard error of 0.051, sample size is 26, so the degrees of freedom is 24. We lose 2 degrees of freedom estimating slope because it's made up of 2 variables. From the printout, the sample slope is 0.018, and the LSR line is y hat equals 49.10 plus 0.018x. The test statistic is t equals the 0.018 minus the assumed population slope of 0 divided by the standard error of the slopes of 0.051. Here is the sampling distribution of slopes that would occur due to random chance if the null were true. Our slope of 0.018 is only 0.35 standard errors above 0 and nowhere near the critical t-score necessary to reject the null in this two-tailed test at a 5% lowest significance. Because the probability of type 1 error is much greater than 0.05, we fail to reject the null. The evidence fails to suggest that there's a linear relationship between admission price and money spent on food and merchandise. Returning to the sample of 51 used in the previous videos, we can see from the computer printout that the slope of 0.76 has a t-score of over 14 and a p-value of virtually 0. We would reject the null and conclude a positive linear relationship exists in this case.